So as you deal with 3D figures and problems that deal with those 3D figures, you may encounter some inscribings, right? And if when I say that a figure is inscribed in another figure, right, it's positioned in such a manner, right, that obviously its vertices are touching that outside figure or that external figure. So there's that one figure that's enclosed inside another figure. And so it can get confusing depending on the diagram you see. So I'm not going to be drawing any diagrams here, but I just have three important rules that I really want to indicate or share with you here, because I think if you understand these three rules and you already know the formulas, then it's just about applying that information to problems. So the first possible inscribing I have is that a cylinder may possibly be inscribed, right? A cylinder may be inscribed in a sphere. So a cylinder may be inscribed in a sphere, and in that case the diameter of the sphere is equal to the diagonal of cylinder. So cylinder inscribed in a sphere, right? The diameter of the sphere is equal to the diagonal of the cylinder, right? And so obviously, you may need to use the Pythagorean theorem to determine that diagonal, right? Again, it can be found by you knowing the diameter and the height, right? And so you can use the Pythagorean theorem there to determine the length of the diagonal, but it's important to understand that the diameter of the sphere is equal to the diagonal of the cylinder. Now the second one is a sphere is inscribed in a cube. So sphere is inscribed in a cube, right? In this case, the diameter of the sphere is equal to the length of the cube's edge. Right, so again, what this means is that if you have a sphere inscribed inside a cube, right, the diameter of the sphere, and you know the radius, just multiply that by 2, that will be equal to the length of the cube's edge. And really, you can think of this visually. Cube's edge is really the side length of the cube, right? So the side length of the cube is the same as the diameter of the sphere. So it's more like saying that there's a line here, right? There's a sphere, there's that line, that's the diameter, and that diameter is really the length. It's that length of the cube, right? Any side length of the cube that you take. The third one is that a sphere is inscribed in a cylinder. So if a sphere is inscribed in a cylinder, right, then they have the same radius. So they have the same radius. So a sphere is inscribed in a cylinder, right, they have the same radius, and obviously if they have that same radius, then you're really saying that obviously sphere has a diameter, and then the cylinder could possibly have a diameter as well. They will also be congruent. So really you see that in cases 2 and 3, a sphere is being inscribed in a cube and sphere is being inscribed in a cylinder, right? The first one, however, it's a cylinder being inscribed in a sphere, right, where the diameter of the sphere is equal to the diagonal of the cylinder, again, for which you have to use a Pythagorean theorem. This can get a little bit complicated, but again, if you just memorize these rules, right, and then you can apply them later, it should not be that challenging. So thanks for watching.